Alright, this is the answer key for the Chapter 7a test, which is on exponential functions and some uses of exponentials. So let's take a look at a few problems on this page. The first problem, we're given that we have a town that has a certain population. The population here is of 3,800 people, that it's increasing a rate of 2.2%. So if it's increasing, it means we have 100% of the people who are currently there, and it's growing at a rate of 2.2%. Which is a total of 102.2%. And then the 102.2% we move into a decimal by moving the decimal place over twice. We get 1.022 as our decimal. That will go as the base of our exponent in the exponential equation that we will write. The exponent will be either x, or we've generally used t for time. And the number in front, which would correlate to the y-intercept of the graph, will be the initial number of people that live there. We can say that that is equal to the population. If I want to know the population in 2024, first thing I want to note is that that means that we're going to go forward 14 years from 2010, which is our starting year. So what we're going to do is plug in those 14 years as a value for t. When you plug that into your calculator, we'll get a value of, let's see, 30,800 times 1.022 raised to the 14th, about 5,153 people. Can't really have a fraction of a person, so you can drop off the decimal. If I want to know what the population was in 2000, to go backwards in time, what we're going to do is use a negative value for the exponent, specifically backwards in time 10 years. Plug that in our calculator. If you hit second enter, it'll recall the last equation, negative 10. We go back to 3056. Here, since we're going backwards, it can be a little bit of a confusing issue about whether you want to round down or round up. I'm going to round up, say that other person is still there. If I want to know when the population will be over 8,000 people, a couple ways to do it. The way that I think will be easiest is to plug our equation into the calculator, 1.022 raised to the x, and hit second graph. That'll take us to the table menu, and kind of look down to see when do we get up to 8,000 people. We have to go farther, 7,000. 8,000 occurs between 34 and 35 years. Starting in 2010, that would mean that we're going to 2044 to 2055 as the year. I'm looking to write an equation for each one of these three graphs. The first one is decay. The horizontal asymptote has shifted down, so let's say maybe it's at negative 3. And the y-intercept is negative, so I don't want to make the number in front of the equation too large. So decay, I could say this is maybe a half. And if it's shifting down 3, don't forget the exponent. If you want to put a 1 or a 2 in front, that's fine. If you put a 3 in front, then the y-intercept would be 0, and that would not be okay. You could also write this equation with a negative exponent, maybe 2 to the negative x minus 3. Our second equation, it's going to be growth. It's going to shift up, so maybe we can say it shifts up to y equals 5. So we can say y equals maybe 2 to the x plus 5. If you'd like to put a number in front, you can. You do not have to. It's growth. Instead of 2, you could use e or any other number larger than 1. Any of those would be fine. If you wanted to write this one with a negative exponent, you could do 1/2 to the negative x plus 5. That would also work. Negative exponents flip the base, give us the reciprocal. This one, a little bit trickier. It has been reflected, so I want to imagine what would the image have been if it hadn't been. Well, that would be growth. So I'm going to say that it's 2 to the x. We've shifted down some, so let's say maybe minus 4. And I need to make sure it flips over, so maybe put a minus 3 in front, and that would work. For questions 3, parts A, B, and C, I want to know if the graph growth, how does it shift, what's the y-intercept? So it shifts up 1 to y equals 1. It's decay, because 1/4 is less than 1. And to find out the y-intercept, I want to plug in 0 for x. So you have 5 plus 1, that's 6. Our y-intercept is at 6. Second equation, 8/3 greater than 1. Horizontal asymptote, -9. Because that 8/3 was greater than 1, we're looking at growth. Find out the y-intercept. That's 2 times 8/3 to the 0. 8/3 to the 0 is 1. 2 minus 9 is -7. Last question, 8, that's our horizontal asymptote. 6 would be growth, which is this shape. There's a negative value in front, so it's going to flip over. So we're going to point downward. Horizontal asymptote at y equals 8. Plug in 0, you get -4 times 6 to the 0 plus 8. That's -4 plus 8, which is 4. To solve these equations, we want to get the bases of the exponents to be the same. So here, the base that we're going to choose is going to be 2. 16 is 2 to the 4th. When you have a power raised to a power, we're going to distribute with multiplication. 3 times x, 3 times 4. Distribute here as well. So 2 to the 3x minus 12 is 2 to the 8x plus 4. So 3x minus 12 equals 8x plus 4. Subtract 3x, subtract 3x, subtract the 4, subtract the 4. We get 5x equals -16, and x is equal to -16 fifths. This one, same idea. First thing, let's add 4 to both sides. We're going to do a little bit of moving things around before we do any other work. Divide by 5 to make the 5 go away. You get 9 to the 3x plus 7 equals 3. I want to change the 9 and the 3 to have the same base, so we're going to change the 9 into a 3 squared raised to the 3x plus 7, and that's equal to 3 to the first power. Distribute the 2, so you get 6x plus 14 equals 3 to the 1, so 6x plus 14 equals 1. 6x equals -13, and x is equal to -16/3. The last portion here, before we get to simplifying with exponents, is to work with compounding rates. So we saw two formulas, a equals p times 1 plus r over n to the nt. That would be for compounding quarterly, weekly, daily, monthly, any amount that's finite. And a equals p e to the rt, which is for compounding continuously. In this problem, we're told we are compounding continuously, so I'm going to pick the second equation. We want to know what the amount is. We start with 2,000. E raised to the 3.5%, we'll write as 0.035 t. I want to know how much money I have in 10 years. So I'm going to plug in 10 for t. Take out your calculator. We say 2,000 times, here we have e, which is just above the natural log, or the ln button. So second ln, and we raise it to the point, not negative, 0.035 times 10. We get that their value of the account will be $2,838.14. I want to know when this function will double, so we're looking for it to get up to $4,000. We can do guess and check, or same idea as before. We can say plug it into our calculator. This time the base of my exponent will be e. So we're going to do e above natural log, above that ln again, 0.035x. Let's start the table off. Let's start at 1. And we'll scroll down, looking to see when we get up to $4,000, $3,3500. 4,000 occurs just between 19 and 20 years. And the last two problems here, we're going to look for, here we're multiplying things that have the same base. So you have h, h, h. If they're on the same side, we're going to add them up. So the numerators, we have 3 plus a -4 divided by, so we're going to subtract that exponent, -5. You have h to the 3 minus 4 is -1, minus a -5 is like +5, so -1 plus 5 is 4. K, we have k to the 7th The only other k, here's a k to the fourth, so it's on the bottom, so you're going to subtract 4. And then the 2 is on the bottom, so we're going to subtract 2. That would be, let's write this here so we have them all on the same line. 7 minus 4 minus 2 is k to the first. And then the last one, we have z. We have a z to the fourth, a z squared, and a z cubed. The 4 and the 2 are both in the numerator. The 3 is in the denominator. 4 plus 2 is 6, minus 3 is 3. Here, a negative exponent means let's flip that fraction that is the base upside down. So n cubed over m squared, and change the exponent to be positive. And then distribute the 4, so you get n to the 12th over m to the 8th. And finally here, we're going to distribute the 4. Before we distribute the 4, though, I want to recognize that this is g to the 1/2. To the 4th, distribute the 4, you get m to the 12th, n to the negative 8, g squared, which if you'd like to, that negative exponent means that it could go, flip it over into the denominator. And that is our test.